How are you doing today? We're looking at analyzing graphs of functions today, and you will definitely need to have your graphing calculator as we go through this. So pause the video, make sure you have that out and are ready to go with entering some stuff. A lot of what we are going to talk about today, we have previously discussed in class. So some of this I will breeze over as far as how do you do that in your calculator. If you're not sure how to do something in your calculator, you really should probably be watching the YouTube videos that I have for doing special things on calculators. This will probably be fairly quick because I can't really do the graphing calculator business in the video. Let's see what we've got. So we're analyzing graphs. So we've got these graphs, and there's certain things that we're always looking for on these, and so we'll have different topics in your notes. The first one is to talk about domain and range. Okay, so we have talked about domain, but not really about range. So what you need to do is you need to start off and you need to type this into your y equals. Okay, so if you type this equation in your y equals, I have a little graph here. They're not the best graphs. They're really hard to read. So that's why I want you to also have it in your calculator, because the reality is that's what you're going to be looking at anyways, your graphing calculator. But what we have here on this one is this kind of what it really is a sideways parabola, but it's only the top half of it. That's what a square root function looks like. Okay, so when you're doing domain and range, we've talked about looking at this, and remember on a radical, you do not want you don't want the radicand to be negative, so you decide what is going to make that negative. So what we have previously done, and we've said x plus 4 needs to stay positive or equal to 0. And so then you subtract the 4, and so our domain would be x is greater than or equal to negative 4. If you're looking at a graph on that, and here's an example of what that graph looks like, you're looking at the range of how far left and how far right it goes, because you're looking at what x can be. And x is a horizontal thing. And so when I look at how far left this goes, the left bound, you can't see it here, but you should be able to see it on your calculator, is right here at negative 4. That's the farthest left it goes. So your domain for this, and we would put it in interval notation, it would be a bracket from negative 4, and then you look at how far right this thing goes, and it just goes on and on and on. So it would be to infinity. There's your domain. We could have done that algebraically, that's fine. Okay, but the range doesn't typically work quite as nicely algebraically, so we will go to a graph if we're going to try to figure out what our range is. So for the range, you're looking at the possible y values. So when you're looking at a graph, you're looking at how low it gets and how high it gets. So looking at this graph, the lowest it gets is right there. Okay, and that value is actually on the x-axis. So the lowest it ever hits is a y value of 0. Okay, and then as it goes and goes and goes, it gets a little bit higher, a little bit higher, a little bit higher, a little bit higher, and it will continue getting a little bit higher. So my range should go from 0 to infinity on that, because it gets the lowest it gets is 0, goes on towards infinity. Okay, let's try another one that we have done algebraically, the fractions. If you'll recall, we don't want denominators to equal 0, so we would do this kind of thing. We'd say, don't let that be 0, add the 2, so x can't be 2. All right, here's what a graph looks like when you have a fraction. It actually has two branches on it. It kind of has this little curve here, and then it pops up here and has another little curve here. Now what's actually going on between there, and your calculator won't show this, but there's an asymptote right in through here. And if you'll remember from Algebra 2, an asymptote is a line that your graph will approach but never quite reach. And so where that asymptote falls is at that value that you don't want x to be. So I have an asymptote right here. It's a vertical line at 2. And that means that my graph will come in here and approach 2 but never quite hit it. Now this graph also has a horizontal asymptote, and it's right here on the axis, and you can see that your graph comes down here and gets really, really close to that axis but never touches it. Same thing on this side. Okay, so let's talk about what that means for domain and range. So your domain, that's your possible x's. All right, so I'm looking at how far left this thing goes. Well, it goes forever left. It goes forever left, forever left, forever left, comes up here, gets really, really, really close to x equaling 2, but never quite touches that. And then it pops up here, and it's really, really close to 2, but isn't quite there. And then it just starts going farther and farther and farther and farther on to infinity. So you could write it like this. Typically, this is how you're going to see it in the textbook, though. They're going to say the domain is negative infinity, right up to 2, but we put a parenthesis on the 2 because it never quite reaches it. In union with, it picks up again at 2, but it doesn't touch it, so we do another parenthesis on to infinity. That's what your domain would look like. Okay? It's the equivalent of this right here. I accept either one of those answers. All right, let's look at range. For your range, you're looking at how low this gets. So the lowest it goes on to negative infinity. And then it comes up, 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 up until it hits, well, actually it doesn't hit. The highest it gets is right up there to 0, but it never hits 0. So I'll say negative infinity to 0, and then I'll do a parenthesis because it doesn't hit that. In union with, and again, you're looking at your y values here. So up on the top branch, it's really close to 0 right here, but never touches it. And then it gets higher and higher and higher and higher and higher. So then I'd say the second branch gets me 0 to infinity for a range, possible y values. Okay, so as recap, domain we've done. If you want to do it algebraically, that's fine. But if they ask for range, we're typically going to need to use a graph to figure that out. All right, here's the next topic we're going to look at, the zeros. We've done a little bit with zeros already. Says here, zeros are where your function equals 0, or f of x is equal to 0. So typically what we do is we set our function equal to 0. So if it looks like this, we would change it to a 0 equals 3x squared plus x minus 10. Okay, so let's just talk briefly about what that means and what happens when you're finding zeros. Okay, here's the graph of it. It's a nice parabola shape here. It says, oh, okay, so what is the graph? It is a parabola. You can write the word. I don't have much space, so I'm going to draw a parabola. What do the zeros mean? If you recall that our zeros are just our x-intercepts. So I'd have a 0 right here, and I'd have a 0 right here. Find the zeros algebraically. If I was going to do that algebraically, I'd come back up here, and I would factor. Okay, so if you factor that, I'm going to come down at the bottom and factor. I'm going to end up with a 3x and an x. I'm going to want a 5 and a 2. So that gives me 6. I want a plus 6 minus 5. Okay, so when I set those each equal to 0, my x-intercepts or my zeros end up being 5/3 and negative 2. Now you can't see that very good on my graph, but again, you're going to be doing this in your own calculator so that you can see that better. Okay, so we found the zeros algebraically. Now find the zeros graphically. All right, so we've talked about how to do that. If you're iffy on finding zeros graphically, go back and watch the special video on finding zeros. But basically you're going to second trace. That's where you start. Second trace, and you're going to select zeros. And you go a little bit left, a little bit right of the 0, and then it will hit enter through the guess. It'll come back and tell you these same two values. Okay, the third topic, the relative min and max. Okay, so by saying relative min and max, oftentimes our functions go off to infinity or negative infinity. This example right here shows you that that would just continue on. The relative min and max, which is what we will always be referencing, are just the peaks and valleys in the graph. Not that it goes to infinity. That's never going to be my max. My max is where I have a peak. So like right here, there's a max, and then it turns back around. Okay, a valley is like right here. This is going to be my minimum, because what it does is it starts high, comes down, hits that point, and then it turns back around. So that's what makes that a minimum. All right, so we're going to find the min and max. And this is a nice textbook definition here. It says a relative max point has a y value that's greater than the y value on either side. So what they're saying is this point right here is higher than the point on either side of it. All right, that makes it a peak, or makes it a max. All right, now we're going to be using this same graph a couple times for our next slide also. So take a minute to go ahead and put that in your calculator. Pause the video because we'll use it a few times. We also will be, this you maybe have done min and max and are comfortable with that, but the next thing we're doing will probably be new. So seriously, really, take the time. Pause the video. Type that in. Do a Zoom standard on it. All right, so once you have that graph, we're looking for this maximum right here. You're going to go to second trace and choose max. You're going to go a little bit left, a little bit right, hit enter through the guess, and get this ordered pair right here. Okay, so when you get that ordered pair, now here, this is going to be different, and I'm sure it's different because I'm kind of picky about this, sorry, but I don't want you to write the ordered pair. Typically, if we're going to be doing this, and in college algebra, you're finally getting into some stuff where there's a lot of application. It's not just randomly working through equations that don't mean anything. This function will represent something. Maybe it's a profit function or something. And when I'm looking for my min or max, I'm looking for my minimum profit or minimum expense or maximum profit, or it means something. So when you find that max, I'm going to want your answer as a sentence, not as an ordered pair. But the first thing you have to do is go find your min and max. So take a minute and go through that second trace and go find your max and min, and go ahead and sketch a graph so you know what you're looking at, and write those ordered pairs. Pause the video. All right, so this one came out beautifully, and rarely does that happen, but we got some nice ordered pairs for our min and max here. And the way that I want you to write this is to write out a sentence, and it's in this format that I have right here. I want you to write, the max is. Now, if this is a word problem, and this one isn't yet, but if this was like a profit function, you would say something like, the maximum profit. I'd want you to describe what you're talking about, the max. Now, when you're looking at a max, you're looking at the y value there, when the y value is at its highest. So the max is always the y value. That's kind of why I'm picky about this. When you say that this is your maximum, do you understand that it's really 2? Or do you just think of it as an ordered pair? 2 is what we're looking at. It's how high it gets. So you would write then, for this example, you'd say the max is 2 when x equals 0. Now, if this was a word problem of some sort, then you'd say the maximum profit is $2 when I sell 0 items, or something like that. Okay? You would like really explain what's going on in the problem. All right? I'd also do the min the same way. I'd say the min is, and I put the y value, which is -2, when x is equal to 2. I want you to recognize that the min and the max is actually the y value, and I want you to understand what it means in a problem. So make note of this. I'm kind of picky about the min and max. Okay, here's our next topic, increasing and decreasing functions. This might be new for you. I'm going to use that same function that we had earlier. It's going to be nice to already know what those two ordered pairs were. So remember, that was a 0, 2, and this minimum was 2, -2, I think. Okay, so when you're looking at when your function is increasing or decreasing, it's like, again, if you had a real problem, you're looking at what time period is your function or your profit increasing, or at what time period is it decreasing. So when you look at this graph, You are always looking at it from left to right and noticing if your graph is headed up or not, or maybe it's headed down. But you're looking at your x intervals, always your x intervals. This is tricky. So when I'm looking at when is it increasing, decreasing, or constant, let's start going from left to right. So starting on the left, I'm headed upward. So my function is increasing. And what I'm putting is an interval, and I don't care if it's parentheses or brackets on this. We usually just use parentheses. It is increasing from negative infinity when I started, and it increases until I get to this value. Now, it's tempting to want to write, oh, it increases until I get up to 2. But it's not the 2. It's not the y value. I'm reading it left to right. So it increases all the way until my x value gets to a 0. Until I get to 0. So I write increasing from negative infinity to 0. Then my graph starts to head downward. And it's going to head downward all the way from 0 to 2 in this range right here. So then I'm going to write decreasing from 0 to 2. Those are x values I'm putting in there. And then it starts to turn around and it starts increasing again, all the way from 2 to forever. All right, so I'm going to go back up to my increasing category here and go from 2 to infinity. It increases. X values. Got to remember, putting in x values anytime you're talking where the function increases or decreases. If you're going to do this type of a problem on your calculator, you really have to know your min and max first. So that will be important. That's how you do it on your calculator. You got to find your max and find your min, and then go look at it. Remember the min and max, you looked at the y values, increasing, decreasing, you're using your x values. Okay, so let's talk even and odd functions. Next category here. When we're looking at a function, we can tell, we kind of label it as an even or an odd function based on its symmetry. Even functions will always have y-axis symmetry. Odd functions have origin symmetry. Now, I always remember that because odd and origin both are O's. That's my trick to remember odd and origin. Now, notice I don't have anything with x-axis symmetry because if you remember, something that has x-axis symmetry actually is not even a function because it doesn't pass a vertical line test. So that's why we don't use x-axis symmetry. So y-axis is an even function, origin is odd, and remember when we did our symmetry earlier, we were always looking for that squared item because that squared would make the negative go away. Okay, so anytime something is squared, we look at it and it's going to be an even function because it's going to have that y-axis symmetry because I'm going to square my x. That negative doesn't matter. If it's going to have an odd power or odd function, it's going to have origin symmetry because it's going to change the sign. If I take a negative something and I cube it, a negative x cubed is going to change it. It is going to go negative on me. So I'm really just looking at, here's the shortcut to it. You're really just looking at powers. Now, that only works if it's a nice, what we call a polynomial function that has just powers. There's no fractions or radicals or anything like that. If that's the case, we don't have to do our y-axis symmetry test and our origin symmetry test. I mean, we can, but if you can just look at it and pay attention to your powers, you can tell if it's going to be even on or an odd one. So when I look at this one, do you see that it has even power, even power? So if I was doing a y-axis symmetry test, I'd plug in a negative x. This one, it wouldn't matter. The square would take it away. This one, the 4 would take it away because it's an even power. Since these are both even powers, I could plug in a negative x and it wouldn't matter. I'd get the same y back. That would be y-axis symmetry. So we would call that even. Any of these that have even powers, and they have to all be even powers, not some evens and some odds. Okay, so let's take a note over here. If you can look at a function and it has all even powers, then that's going to be an even function. If it has all odd powers, that's going to be an odd function, and it's going to end up with origin symmetry. If you have some of both, some evens and odds, then it's a neither. It's not going to have any type of symmetry, which a lot of functions don't have symmetry at all, and that's fine. Okay, the one thing you have to pay attention to is the constant. When you have a constant, remember that a constant is a number, just a number. So that's this 2 that I have right here. That and this 2 right here, or this 1, those are constants. You have to remember that what's happening, like when you go down with your power, this is to the 5th, to the 4th, this is to the 1st power right here. So what's the power on x here? Well, it's really an x to the 0, but x to the 0 is just 1, so it goes away. That's going to be the case on any of these. Oops, not squared. Where did that come from? Okay, that's going to be an x to the 0 there. All right, it turns out that 0 is an even number. So anytime, regardless of whether the number is odd itself or if it happens to be even, it is considered an even power. So constants are even powers, always. Okay, so that's kind of the only trick to this. All right, so this is our shortcut. We're not going to do our symmetry tests here. We're just going to look at our powers and see what happens. So I looked at the first one and decided everything was even. So I went with even function. Let's look at g of x. Here I have an odd, but 0 is an even. So that is going to have both. So that would be a neither situation. It doesn't have any type of symmetry. It's not an even or an odd function. Okay, let's look at this next one. I've got a 5, I've got a 3, and I've got assumed to be a 1 right there. Excellent. Those are all odds. So that is an odd function. Let's look at j of x. Here's a 2. Remember that constants are always considered to have even powers. So that's an even. That's an even, that's an even. So this is an even function, and thus would have y-axis symmetry. Okay, let's look at k of x. I've got odd, even. Oh, I'm done. I can't have both. All right, so that means that this is not even or odd. It's not going to have any symmetry whatsoever. All right, last one, p of x. I've got an odd, 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 and this is assumed to be an x to the 1st power. So that's odd. Everything's odd. That's an odd function. All right. So you still may have to do some symmetry tests that we learned earlier in this chapter. But this is kind of the shortcut to doing symmetry tests if you're just trying to decide if it's an even or an odd function. Okay, so that's all of the topics that we're going to talk about. There's a lot of things that are very important that are going to come back to us over and over. So please make sure you take the time to really understand those different things that we analyze functions with. All right, so your homework tonight is going to be 1.4, but I wanted to throw one more thing at you that's on your homework. They have a problem that they want you to do something with, and they tell you f of 3 is equal to 8. Or that's not that, but they have something like that. You need to remember what that represents. That's that function notation. What that means is that if you plug 3 in for x, you get 8 back for the function value or the y value. So this is a fancy way of just giving you an ordered pair. If x is 3, y is 8. And so if they give that to you, and they will on your homework, you just convert that to an ordered pair 3, 8, and then go do what you're familiar with it. All right. Good luck. Have fun.